All right, so we're here with 4.2 binomial distribution, and definitely have your calculators handy because there's either going to be this terribly long formula or this cool shortcut depending on what your calculator can do, but either way your calculator is going to be the one doing it all. So here is the note. Here are the notes. I don't know, so I'm not an English teacher. Okay, so binomial probability distributions allows us to deal with circumstances when the outcomes belong to two categories, like acceptable and defective, or survived and died, or heads and tails, or up and down. I don't know what that would be for, but you know, two choices. Flipping a coin, heads or tails. There's no other choice. There was a, that about got dark with the survived and died. I'm not going to give you an example of that. You can figure that out. But that's what we're focusing on. That's what the bi and binomial distribution is referring to, is the two choices. So here's the four rules. One, it has a fixed number of trials. So for example, maybe you flip a, oh dear Lord, maybe you learn how to write. Goodness. Maybe you flip a coin 100 times. Okay, that's fixed. How many times did I flip the coin? You could tell me. I flipped it 100 times. Okay, the trials must be independent. If I flip a coin and I guess I do it like this, and I land on heads, and then I flip the coin again, that second flip doesn't care what the first one landed on. It has its own answer. It's going to land on its own side, whatever it is. So that's what it means by the trials are independent. The first one does not affect the second one. Just by contrast, something that would be dependent, let's say I had a deck of cards and I took one out. Okay, that's the probability. It was 1 out of 52. Then I stick it in my pocket. Now I only have 51 cards left. So depending on what that card was, the probabilities have now changed about what's in my hand. Because if I took out a black card, well, now the red card has a higher probability of being chosen, and vice versa. If I took out a 4, well, then there's less 4s in the deck, so that probability has been affected. So that's what I mean by dependent. Independent, you roll the die, roll it again, roll it again. Every time, it doesn't matter what you landed on before, you'll get a fresh start each time. Okay, each trial must have all outcomes classified as success or failure. We can only have our two choices, our two categories, and one of them is going to be good and one of them is going to be bad. It depends on what we're talking about. You might think survived and died. Well, survived must be the success. Well, I'm going to argue that it doesn't must be the success. It kind of just depends on the way the question is worded. So you'll be able to tell by the question which one's a success and which one's a failure. And then the probability of a success remains the same in all trials. And it will remain the same because they are independent, like we said in number 2. So this lovely guy right here is the formula to calculate the probability of something happening. Like heads or tails, like not heads or tails, but like 2 heads versus 5 heads, you know, for flipping it 100 times. The probability of a success is P. So later on, you're going to be like, wait, what's P? And I just want to point out, I've talked about X and N before, and I said they're important and they keep coming up, and you can see that X and N are still coming up even though we've changed the topic. Same thing with P and Q. Starting today, we're going to talk and define them. The P and Q are always going to be the same throughout the rest of the course, and they're going to keep coming up. So this is one of those things that's just, you got to kind of have to keep coming back to. So you may want to even put a little sticky here because the P's and Q's will come up time and time again. So the probability of a success is P, and the probability of a failure is Q, which is defined as 1 minus P. So if I tell you that something will be successful, the probability of it being successful is 90%, then the probability of it being a failure is 10% because we take that whole minus that 0.9 to get 0.1. This little note, sampling without replacement, that's just something we will kind of get into more detail later with this whole N right here, the sample size, but it's not important right now. So I'm going to unmark it because we're going to not use that right now. So just to remind you, because we have talked about these before, N is the number in this case, the number of trials. It's always the number of things we're talking about. So in that case, trials. And then X is going to be the number of successes. So N is the total number. X is the number we're looking at for that particular example. So what's the probability of this? What's the probability of that? That will be our X, whereas N is the total. Okay, so first, let's just talk about these four. Oh no, I haven't even touched that formula there. We'll get to it on the next page. But let's just talk about those four rules right there. So the first question, it says, surveying 12 jurors and recording whether there is a no on, they've been asked if they've been convicted of a felony. So let's go down the list and see if this is a binomial distribution. Oopsies. Are there a fixed number of trials? So I'll just kind of write it out. So for one, and this list is going up to this list up here. One, there's 12 jurors, so there's a fixed number of trials. Two, the trials must be independent. So that is yes, because each person answers for themselves. Person, oh, that's a weird R. That's a weird N. Each person answers for themselves. Just think about it this way. Are you sitting next to somebody? I'm sitting by my dog. I don't think that counts. You're going to see somebody today, or maybe you already have. If they answer the question, have you ever been convicted of a felony? Does it really matter what their answer is? Will that affect you? Will that change your answer? No. Their answer is independent of your answer. So that's why this is yes for number two. Number three says success or failure. So we're asking them a question. The answer is either yes or no. So this is good, going good so far. It has a fixed number of trials. Each thing is independent. There's two possible answers. And finally, is the probability equally likely? Yes. Everyone in that room is equally likely to have been convicted of probably, because if you're convicted of a felony, you can't be on jury duty. So I don't know. Am I thinking too hard? Okay, we'll move on. I wanted to give you a clear-cut example of where, so this one is yes. I wanted to give you a clear-cut example of where the answer would be no, and that's going to be in B. B is going to be no because we know the number of trials, so that's 250. Each person's answering for themselves, so they're independent. But on the third, which is each trial must have each trial must have all outcomes classified as a success or failure. Talking too fast. That means there's only two choices. And if you ask how many children are in your family, people don't have only two answers. They have many answers. Somebody might say they have 0 children in their family. The next person might say 1. Somebody else might say 7. Someone else might say 4. So this is no because there's many answers for this question. So you would have to say, are there children in your family? Yes or no. That would give you a success and a failure. Okay, so now that we know what it is, let's, we're just going to practice the variables, then we'll look at the formula. So here it says, is this a binomial distribution? So let's look at the problem. I don't know why I'm yawning. I slept very well last night. Maybe I need coffee. Next video, I'll make coffee. Okay, when an adult is randomly selected, there's a 0.85 probability that this person knows what Twitter is. Suppose we want to know the probability that exactly 3 of 5 randomly selected adults know of Twitter. Is this a probability distribution? Well, we have 5 trials, so we're asking 5 people, so that's a fixed number. What's the second one? The independent, yes, someone's knowledge of Twitter is not dependent on the next person's knowledge of Twitter. Each trial must have a success or failure, and yeah, the answer is yes or no. It's equally likely that someone knows about Twitter as that they don't. So yes, this is a binomial distribution. I know I'm going through this fast, but I'm just going through these steps 1 through 4. I just have them written on another sheet of paper. That's why I keep looking over. So just go through those steps if you're unsure. All right, find the values of N, X, P, and Q. So going back to that chart or that box from before, N is the number of trials. So there's 5. X is the number of successes. So in this one, success is defined as someone that knows what Twitter is. I know that for 2 reasons. 1, this gives me the probability that they know what Twitter is. And 2, we're trying to find the probability that exactly 3 people know what Twitter is. So knowing what Twitter is the success in this example. The probability of that success is 0.85, which I just highlighted above. And the probability of failure is 1 minus 0.85, so that is 0.15. Okay, so let's just, are we gonna do this later? No, we're not gonna do this later, so let's do this now. Let's find that probability. So I'm gonna practice the calculator. The probability of 3, so 3 out of the 5 people knowing what Twitter is. We are going to use our calculator, and we're going to use, I'm just going to scroll back real quick. This chair is super uncomfortable. I hate making videos in my room, but everyone's so noisy out there right now that this is my only quiet place. Okay, this formula that I put in a box, this is what we're going to be using. So if you just have that paper handy, you'll be able to see where these are coming from. But the probability of 3 is 3 factorial over 5 minus 3, oopsies, I already started off wrong, huh? And 5 factorial over 5 minus 3 factorial times 3 factorial times 0.85 to the x, so 0.85 to the third, times q, which is 0.15 to the 5 minus third power. Doesn't really matter where the parentheses are, but I guess 3 outside would be better. Okay, so you should know where, maybe you don't know where some of this is. Okay, so first of all, factorial. On my calculator, I'm going to type in the 5, and then the exclamation point comes by hitting the probability button. And then when I hit that, the third one down is the exclamation point. And so just hit the probability button once and you'll be able to see where that is. Then you have to put it in a fraction. I'm just going to do this once just to remind, or just to show everyone how terrible it is, and then we'll do a shortcut. Probability button. Okay, there it is. Got my fraction going. So on the bottom, I have 5 minus 3 factorial. This is on a graphing calculator too. So if I don't remember off the top of my head what it is, it's very similar. I think there's a probability button. It's very similar on that one. Oh no, I think you hit math and then you hit over to probability, PRB. But it's, if you have that file that I posted, just print out that first couple pages and you'll be able to see. Okay, 5 factorial over 5 minus 3 factorial times 3 factorial, and then I have 0.85, and my exponent, I don't know if we talked about it yet, it's this little caret. It's kind of catty corner from the 7. It's a little caret and it puts it up at a 3, and then I have to hit over, so I have a big fraction or a big cursor again, and then I do 0.15 caret, and I'm just going to put 2. I know what 5 minus 3 is, so I'm going to put 2, and I get, all right, 4 decimals sounds good. I don't know, guess I could have done less, but that just looked good. Okay, so if you followed along and you got that, great. Some of you are like, what's the exclamation point again? So Google your calculator if you don't know how to find the factorial or the exclamation point. Google your calculator if you don't know how to find the exponent button. But while we're Googling, we really want to look for the combinations button, because that is even better. You know what? I'm going to do it on the next one, because the next one I have more space to write. So we can go back and try it with that one again too. But let's just go to the next one and I'll show you the shortcut on your calculator. So for here, the probability of getting exactly 2 girls when 5 babies are born. So N is 5 because there's 5 babies, and X is 2 because 2 of them are girls. Now, what is the probability of a success and what is the probability of a failure? In this case, success, it always goes back to what the X is. Success has to do with girls. So what's the probability of a girl being born? 1/2. What's the probability of a boy being born? Also 1/2. You can get that either by subtracting or just thinking about it. And just remember, we're always going to the simplest scenario. This is not, what class would you talk about this in, philosophy? Or I don't know, this isn't a class where we argue things like, well, you know, if a woman has 2 boys, then the chances that she has a 3rd boy are greater. Yeah, whatever. We're doing basics. It's either a boy or girl, 1 out of 2. Okay, so now I want to put this in my calculator, and I don't want to do all that stuff that I did before. So I'm going to use my combinations button, and it looks like this. It's actually not a button, but it is a feature that I can find. And on my calculator, I can find it in the same place as the exclamation point, and probably on a graphing calculator too. I hit the probability button, and I see this as my first, or no, it's actually my second choice. Now, the N comes first. So I'm on my calculator, I'm going to hit the 5 first. And then it's going to say NCR. And then we don't use R in this class, but it's going to be X. So we're going to put our N before the button, X after the button. And so it should look just like, if you forget to hit the 5 first, it might say something like ANS, NCR. And that means you're wrong, because this is just taking the previous answer. You want to make sure that it says the number that you want it to say. So you hit the 5 first, then you go to probability. Again, if you have a graphing calculator, I think you have to hit math first and then go to probability. 5 NCR 2, bada bing, bada boom. And what? That's not the right answer. What did I do wrong? Hold on a second. 5. Probability. It's more fun in a live class because then you could all stare at me while I make these mistakes. Bum, bada, bum. Oh, I know what the problem is. Yes, no, that was actually right. NCR actually doesn't take care of everything. It just takes care of the fraction part. So what we would want to do is we want to still, I knew I'd figure it out. We want to still continue on with our decimal to the power. So I have all that, and then I do yeah, that's right, 0.5. Probability of P to the, which one is it? Probability of P to the X power times probability of Q, probability of a failure, to the N minus X power. There we go. Okay. So let me go back. I'm going to hit that 5 NCR 2, and then I'm going to continue on by hitting times 0.5 squared times 0.5 to the 3rd. Oh my, I'm hitting all kinds of buttons. And still getting the wrong answer. I'm going to pause the video for a second, because that's the beauty of not being live, is that I don't have to have you all stare at me while I figure this out. I'll be right back. All right, so apparently I forgot to hit a times button in my calculator. So this is correct. I just was typing it in wrong. I knew there's something wonky happening. This is correct, and that is going to equal 0.3125. So if you're getting that answer right there, you also typed it in correctly, or in space correctly. This times, I sometimes forget to write. I wrote it down, but then I forgot to type it. So make sure you are using the multiplication button as well. Okay, now that that is squared away, there's only 2 more problems. So I'm going to be using this NCR formula more because I like it better than all those exclamation points and fractions. And so here we have the probability. Actually, this is very similar to the first problem, but we have at least 3 right here. So this is going to be a much longer problem, but since we have our handy dandy calculator, it should be pretty quick to calculate. And so the probability of at least 3 means the probability of 3 plus the probability of 4 plus the probability of 5, because it's the total is going to be 5. So I'm going to do this problem 3 times. In this problem, actually, I'm not, because it just says to find the values. I will write the values. I will write the answer, so that way, oh no, why wouldn't we just work it out? We have all the time in the world because we're on the computer. Okay, so in this problem, n is going to equal 5 because there's 5 adults. X is going to equal either 3, 4, or 5, depending on which one we're working on. P is going to equal 0.85, and Q is going to equal 0.15. And so I'm going to work out each of these individually, and then I will put each answer down, and then we will add it up. So go ahead and play along, do the calculations with me, and then actually, no, you already know how to do this because there's nothing I can show you on your calculator. Do this like we did number 3, and then I will go do it as well. And then when you come back, I will have the answers up. All right, I will be right back, and you pause it as well. And we are back. So let's get back to 4.2. And we already did this first one up above. So if you did it again, you should have the same answer as number 2. And if you just notice that was the same, you can just copy it down. But there's the answer for the probability of 4 and the probability of 5. And finally, the answer for the probability of all, oops, I can't choose this color. The probability of all 3 of those added together. So it's the same that we've been doing. We are just taking a little more time because we have to do it 3 times. All right, so finally, this one is going to take a bit. So let me just insert another sheet of paper real quick. And here we go, in case we need more room. But here we have the same thing with the Twitter going on. This difference here is this at least 1 adult. So we want the probability that X is 1 or greater. So that's going to look like the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. Now, on one hand, we already did 3 plus 4 plus 5, so I guess this wouldn't take too terribly long to do the 1 plus the 2. But that's not always the case. Sometimes the problems are not related at all, so there has to be an easier way. So the probability of at least 1 is the same thing as the probability of everything minus the probability of nothing. So the probability of at least 1 adult means all of the choices except for no adults, except for 0. So now, instead of having to add up 5 different decimals, we really only have to do the 1 decimal and subtract it from 1. So this is going to be a lot easier. Now, you might be concerned, or you might not care, one or the other, about having all these zeros in the problem. And there's nothing to worry about because a 0 in an exponent is just equal to 1. And if you did it the fraction way, you might notice we have a 0 in the denominator, but it's actually a 0 factorial. And that is also equal to 1. Or 0 factorial is equal to 1, so it's allowed to be in the denominator. Okay, so I'm going to use the N choose R button again. So I have 5 choose 0, and my 0.85 is going to be to the 0 power. My 15 is going to be to the 5 power. So I have, this is what I typed in, 5 choose 0 times 0.85 to the 0 power and 0.15 to the 5th, or the 5 minus 0, or 5th power. And I get this really, 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 really tiny number that's really even too hard to write because there's so many numbers. It looks like it's a member, but I guess there's an N and a U in there. Okay, so what I'm going to do on my calculator is do 1 minus, and I'm going to hit the answer button because I don't even want to write down this number. It's so small. But if I do 1 minus and then I hit the answer button, so for me, it's above the minus sign. It says ANS. It's in green. So I'm going to hit the green button and then I'm going to hit ANS. It says 1 minus answer. And then I get a number that I can better look at. In fact, there's a bunch of 9s, and then I'm just going to put the 2 right there just so you can just kind of actually, normally I wouldn't write all this out, but since it's such a weird one, I want to make sure you can see all the digits to make sure you're doing it right. So we don't really need to round. There's our answer, or you could just put 4 9s and have that be your answer as well. But that saved us from having to copy down all of that teeny tiny number with all those zeros in it. It was just using the answer from above and then typing it in. All right, hopefully you learned something about your calculator. I do have some more review problems, but that'll be in the next video. So email me if you have any questions, and I'll see you then. Bye.